Hello everyone. In this video we'll look at the fourth and final predicate derivation inference rule, existential elimination. I have the rule statements displayed on the screen for you. On the left is the statement or the rule statement from the textbook. If we look at this and follow along, it says that we have to have an existential generalization to work with, as well as a subderivation. And as you can tell, the auxiliary assumption that begins the subderivation has to be a substitution instance of that existential generalization. Inside the subderivation, the last line of the sentence can be any sentence of the language. We're going to use the metavariable q for that. And when the subderivation is finished, we can export q to the next outer scope line by appeal to the rule existential elimination. There are three provisos or restrictions on existential elimination, making it the most complicated inference rule we have to work with. Let's hop over here to the rule statement on the right-hand side, which is sort of my own preferred statement of the rule. Again, the rule, starting with the rule input, we need to have an existential generalization. So we have to have a sentence whose main operator is the existential quantifier. I have the variable v there standing for all of our variables, w, x, y, and z. And then the quantified formula needs to include, of course, that variable of quantification. The subderivation begins with a substitution instance of the generalization, which is the result of dropping the quantifier out of parentheses and replacing the variable of quantification with some name n. Then the last line of the subderivation could be any sentence of the language, as long as it respects the three provisos. I'll get to that in a moment. At the end of that, we can stop the subderivation, move to the next outer scope line, and copy down that sentence q by appeal to the rule existential elimination. The restrictions on existential elimination all have to do with the name used in the instance, in the auxiliary assumption for the subderivation. And these restrictions are listed in the rule statement in the book, but here they are. The name that we use to formulate the instance cannot appear in the quantified formula. It cannot appear in the context of this existential quantifier. In other words, on this side, it can't be already in here between these parentheses. Another proviso is that the name A cannot appear in any live assumptions, any undischarged assumptions whose scope lines are still growing. The third restriction is that the name A cannot be exported outside of the subderivation by appeal to the rule existential elimination. Those three provisos all are restrictions on the name used to create the substitution instance of the existential generalization. I have a shortcut. Instead of keeping track of all three of those provisos, I have one proviso that I'd like to recommend, and I call it my super proviso. So you will not see this discussed in the textbook, and you won't see this notation in the rule statement in the textbook. I'm adding it here. What I'm going to do is add a little flag, a little signal here, a little reminder to ourselves as we apply this rule, that the name we're using here to create the substitution instance of our existential generalization, that name is entirely new to the proof. It doesn't, not only does it not appear in the existential generalization or in any undischarged assumptions, it's entirely new to the proof. It doesn't appear in any sentences above the subderivation. And also, it is not allowed to be in Q. It's not allowed out of the proof. So this is another way of saying that the name is restricted entirely to this subderivation. It doesn't appear anywhere above or below this scope line. And so over here, what we'd do is we'd annotate with a little n. N is our signal that that name is restricted to this subderivation. It doesn't appear above it, and it's not allowed to appear below it. I will confess that this super proviso is actually stronger than the 3 provisos that the book offers. There will be a few legal moves you could make that would violate the super proviso, but would respect the book's 3 provisos. However, I think there are always workarounds, and that it's easier just to remember the super proviso and do your plan accordingly instead of trying to keep track of all 3 provisos. But I will say here officially, in doing your proofs, what matters most is that you respect your proofs follow or obey the 3 individual provisos offered in the book. I'm simply offering you this one overly strong proviso as a way to keep things a little simpler. So let's see how existential elimination works in a proof, an example. So suppose that we want to derive this statement, derive. There is a y, dy, g. And we've got a couple of assumptions to work with. First one is, for all x, if bx c, then dx g. That'll be our first primary assumption. Our second primary assumption says there is a z such that b z c. That will be our second primary assumption. So let's introduce a scope line right about here. And underline our primary assumptions, I think, about here. And let me see if I can clean that up relatively quickly. Good enough. We're going to work this proof from the top straight on down to the bottom. If you use the super proviso that I'm recommending, anytime you have a mixture of universal quantifiers and existential quantifiers to work with, as we have in this situation, my advice is that you should apply or work on your existential quantifiers first. So let's start a little subderivation here for our application of existential elimination. Okay, so we're going to need to create an instance of our existential generalization on line 2. To do that, we'll drop the quantifier. There's a z. And the result will be the letters B, Z, C. B, Z, C. Now, we can't leave the z there because that's a free variable. So we have to do a replacement. We have to replace that name z, or that variable z, with a name. There are restrictions on existential elimination. I've already mentioned them. 2 of them are relevant here. The name we put in this space, the first position following the 2-place predicate B, cannot be the name C, because that appears in the existential generalization we're working on. It also cannot be the name G, because G appears in a live assumption. So we have to choose a different name, and I'll choose A, and I'm going to put a little A in here next to my auxiliary assumption to remind me this name is not allowed out of the subderivation. That way, when the proof is finished, I can say the name A was totally isolated to the subderivation. It didn't appear above the scope line, and it won't appear below the scope line either. So this is in effect saying, whether you use the super proviso or not, this is in effect saying something stands in relation B to the individual C. Something stands in relation B to C. Let's call it A, okay? That's all we're doing. And because A doesn't appear in any live assumptions and it doesn't appear in our existential generalization, A is a neutral instance. It's an arbitrary instance. So this is our assumption for existential elimination. And from here, we can just keep moving with our proof. We got our eye on this target sentence up here. We're going to try to work our way towards something that looks like it. The next thing that we're going to want to do is to apply universal elimination to line 1. So we're going to drop that quantifier in the outer parens and replace the variable x with some name. There are no restrictions on universal elimination. We can apply universal elimination to any universal generalization. We can replace the variable with any name we like. But if we look at it, we should want to apply, to replace the x's with a. BAC or should DAG. And the reason we should want to do that is because it gives us input for another rule right away. I have a conditional in line 4, if BAC then DAG, and I have the antecedent of that conditional in line 3. So this gives me input for conditional elimination. I get to write down DAG from lines 3 and 4, conditional elimination. This new line, line 5, has the name A in it, so it cannot come out of the subderivation. A is to be restricted to this subderivation. But if we look at line 5, it looks an awful lot like our target sentence. We're one move away. I'm going to extend the scope line a bit, even though I worked so hard to make it with a nice straight ruler. There's a Y, D, Y, G from line 5, existential introduction. When we get to that statement, there's a Y, D, Y, G, we've arrived at a sentence that doesn't have an A in it. That means we can copy it down outside the subderivation along the next outer scope line, D, Y, G. Now, how do we get that? What are we going to do to annotate that move? Well, it's an application of existential elimination. It doesn't look like existential elimination because it has an existential quantifier, but it's an application of existential elimination on lines 2 and 3 through 6. So let's take a look at that. Existential elimination takes two things as input. The first thing it takes is an existential generalization. That's line 2. The second thing it takes is a subderivation, 3 through 6. 3 through 6 is the range for that scope line. And we know that that's an application of existential elimination because the auxiliary assumption on line 3 is a substitution instance of the existential generalization on line 2. And the sentence that we're writing down when we're applying this rule is the last line of the subderivation, and it does not contain the name used to create the substitution instance in the auxiliary assumption.